But wait, there's more. In this part 4B video, I'll try to keep it really short. I forgot. The most important thing after doing your analysis is actually using your model to make a prediction and to make sense of the situation, to find the connections. So I'll keep this really brief. You've already gone through, you've modeled your data, and you've said, okay, I've got a linear model, I've got an exponential model. And if we like our exponential model even better, because it has a lower mean squared error, we can use it to make predictions. And that's really based on this model right down here. So what I can do with this model is just plug in any x value into it to estimate a future population. So let's just take two situations here, and I'll show you what I'm talking about. Let's say up here, our time values went up from 0 to 39, and we've got some missing values here. So let's go ahead and do a couple of predictions. Let's predict 20 years, and let's just go 50 years, some far outside our data set. So I'm just going to plug in some, I'm going to put time. I'm going to put in 20 and 50 from the start, and I'll put prediction. And again, this is going to be based off the exponential model. I could do it for linear as well, or any model. And simply what I'm going to do here is equals, starting with a y-intercept, multiply it by the rate, and raise it to the power. And in this case, the power is the x value right there. Bam. All right? And that gives me a prediction. And it says in 20 years, I should have 79 people or whatever, almost 80 people. And if you look back at your original data set, you can say, oh, well, that's pretty close because it was 80 for 21. So that's actually really close. You'll notice here, though, that there's an error, a value error. And I want to take just a moment to explain what's going on here. If you hit the F2 key or function F2, it'll show you how to edit a cell. And you'll notice when it copy and pasted the formula down, it shifted everything down. So it moved me off the intercept and the rate. And so that's a little bit of a problem. I'll just show you a little Excel fix on how to do this. So first I'm going to just hit escape and delete that. If I go back to my original formula and I edit it, I can just click up in here. If you put dollar signs around in front of the column, it won't move columns when you copy and paste it. And if you put them in front of the row, it'll do the same thing. Basically, it's a cell reference lock. And it's a really helpful trick because I can now use this formula again and again and again. So I can copy it, and now I can paste it. And this time when I copy and paste it, I'm going to click on here, I'm going to click up here, and you'll see it highlights. It kept the intercept where it was supposed to be. It kept the rate where it was supposed to be, and it's just referring over. That's really handy because now if I wanted to do a bunch of crazy things like 51, 52, 53, I don't know, 60, say I wanted to go year one, whatever, I could take that formula and I could drag and drop and make predictions based on the model. And it's still using the original intercept and rate in the model. So that little dollar sign trick is a really good one to know if you do any data analysis. All right, I'm at almost 4 minutes. Final point here, making sense of the situation. If you continue on to college or take any statistics course, you'll learn more methods for how valid your model is or how well it works. And if you look at the news or any kind of data research, there's all these models and predictions of what's going to happen in the future, how well your model fit in the past, climate models, COVID models, financial models, you name it. There are different metrics to analyze how well your model fits. Just looking at the picture here too, you can see that this red line actually has a fairly good fit. It seems to match the data well. That isn't a very technical answer, but I think it's a good enough answer for now. I can use this model to predict population over time. For a certain point, at some point, things are going to change. There's going to be a different level off. There's going to be some factor that changes things overall. And this is where you want to look at your model with a limited domain. Hey, my model is good for a certain situation, but beyond this situation, it's too far. There's too many things that could change. That means population probably isn't going to grow exponentially forever. There's going to be other factors that are going to make it go down or shift. I'm going to leave the video at that. Thank you for your time and patience. Thanks for sticking with me on this.